So we're going to start our discussion of this new case study by explaining what the RSocket ZippyQuotes app does and kind of how it's designed and organized. The basic idea here is to use the RSocket protocol and the RSocket framework integrated into Spring to exchange binary messages asynchronously to and from a Spring microservice using our good old friends, the Project Reactor reactive types. And you can get this in my GitHub repository, as always. This example also shows how to use the RSocket security and authentication features, which are a little bit more esoteric, but turn out to be quite useful once you find a pattern to follow. So let's take a look at how this works. So we have a client, and the client will asynchronously connect to the server and authenticate itself. And then once it's authenticated, it'll send and receive binary messages using the Spring RSocket APIs. The server will receive the connections and then route the incoming messages to the appropriate endpoint handlers and process and consume and respond to these binary messages asynchronously. And of course, that requires everything to be authenticated before the client can actually start to send messages. If you don't pass the authentication test, you don't connect. There's a ZippyConnect controller that receives connection requests and then turns around and forwards them to the ZippyConnect service. Nothing really surprising there. And then the ZippyConnect service performs on the authentication of client credentials. And it also sets things up to handle further communication with the client over time. And we'll take a look at some of those examples too. The Zippy message controller takes the incoming concise binary object representation encoded messages and converts them into Java types and then forwards them to the Zippy message service, which then implements the methods that process the client message requests and return the associated subscription information and ZippyQuotes. And we'll talk more about that as we get further into the example. So how is this thing organized? This shouldn't be too surprising because it looks quite a bit like our other Spring projects. We have a main module, and we have, well, I guess it's really a folder, a package, and a test package. They're not separate modules. They're all part of the same module. And we do this so that we can launch the application from the test program without having to do anything manual ourselves. On the server side, we have the source folder has the server-side classes, which include all the things you're accustomed to seeing, controllers and services, and of course, the application microservice entry point itself. This particular example is a little bit different from things we've looked at before because it's got multiple controllers and multiple services because we want to separate connection activity from actual message passing, just to make it a little cleaner. There's a common folder that includes the reusable project-specific classes, including a security module, which you could tailor to your own needs if you wanted to. There's the utils directory, which just has a very simple class in here that generates random numbers. We've seen this before. And then finally, we also have the resources folder that contains the server name and the port number it listens on, and the ZippyQuotes, the database of 600 plus ZippyQuotes. The test folder drives the client side of all these things. It's got the client folder, which contains the proxies that we use, because we have to handwrite the proxies. There's no equivalent to HTTP interface or retrofit for using RSocket, largely because it's not trying to be a remote procedure call. It's trying to be a message passing, but we can make it a little easier to program by providing our own little proxies. And then there's a client bean that does all the heavy lifting to establish a secure connection with the server. And we'll spend some time on that because that's really cool. And finally, there's a test driver that connects with the server and then exchanges all the messages and prints out the results. And the test driver also demonstrates the use of Project Reactor's step verifier mechanism, which is a very nice way of being able to test the behavior of asynchronous communication in a quasi-synchronous way, which makes life easier for testing and debugging. So that's the end of the overview of the app.